Question number 3. And by the way, on the AP test, these are spread way out, so you have tons of room to work. So you're not going to be squished for space. You might be squished for time, but not for space. Grass clippings are placed in a bin where they decompose. For 0 to 30, so again, kind of a piecewise thing here. The amount of grass clippings remaining in the bin is modeled by .931 to the T, where A is in pounds and T is in days. I don't really have to rewrite all this, but it's forcing my brain to slow down a little bit to process what's going on. Okay, this is a little bit different. That's the amount that's in there. That is not the rate that it's decomposing. So I will not, most likely, have to integrate that to find out how much is there. Like, that is the amount. In fact, they called it the amount. They labeled it A. Like, they realized that this one's a little bit different than most of the accumulation problems. So that's why we got to be careful here. Part A. Find the average rate of change. Average rate of change from 0 to 30. Average value formula. You got to know that. I bet that's on the sheet that I gave you today. I bet it's on there somewhere. Careful. So there's average rate of change. That's algebra slope. Average value of a function. Again, they even broke it down. Average height, area divided by width. So the area divided by the width. Goodness. Thank you. This one's also a calculator question. So I don't need to show any more work than what I've got. I can go to the calculator and let him do the work. Oh, so I am having to do an integral for the average rate of change. Again, I'm going to take the time to put it in for y1 because I'll probably need it for multiple things. .687 times 0.931 to the x. Quick double check because the calculator's not going to mess it up. You don't want to miss anything because you typed it in wrong. So, integral, math 9, 0 to 30 of y1. Be careful, I didn't put the over 30 yet, so I can press enter and then divide by 30. I could just divide by 30. I guess I could have put it at the very beginning. Like that. So I don't forget it. So the average value of leaves in the pile. Wait a minute. Did it ask for... I should read more carefully. It did not ask for the average. Oh, this is awful. You see my mistake? Yes, this is... I mixed up two things. This is average value. But it asked for average rate of change. So some of you were right. Average rate of change, got to slow down. That's the good old Algebra 1 slope. So A of 30 minus A of 0 over 30 minus 0. Let's see. You can still use the y values or the y vars thing, and you can use function notation with it as well. So y1 of 30 minus y1 of 0 over 30. Average rate of change, not average value. Negative 0.197. A is in pounds, T is in days. So the average rate of change is negative 0.197 pounds per days. In fact, because it says indicate units of measure, that means that's part of the point. You better have pounds per days or you won't get the point. This was only worth 1 point, but you wouldn't get the point if you didn't include the unit. Again, when it says indicate units of measure, that's your tip-off that you better include it if you want all the points. Part B. Find A prime of 15. Using correct units, interpret the meaning of the value in the context of the problem. Okay, well, A prime of 15, that's a calculator thing. I can do that. Let's see, because I don't want to find the derivative on my own. I'd rather let the calculator do it. Exponential decay. Change my window because I want to look from 0 to 30. And it looked like my Y scale was okay, although I don't really need the negatives because you can't have a negative pile of leaves. So there's my decay. I guess I could tweak my my scale to include more up above, but I don't really need that. I want dy dx at 15. So A prime of 15 is negative 0.164. That's another way to say that, if I'm worried about units, is dA dt. So what is my units of, what's A prime units? Pounds per day. Now it said also interpret that. Using correct units, interpret the meaning of the value in the context of the problem. So negative 0.164 pounds per day, what does that mean for this particular problem?
If there's decomposing at negative 0.164.
Okay, so be careful. I like what you said, but if you're going to say they're decomposing, you may not want to include the negative on there.
They're decomposing at a rate
Of 0.164.
pounds per day.
Clippings are decomposing at a rate of 0.164, because the negative is included in the decomposing part. 0.164 pounds per day on day 15. So be careful, because it's not always that, but on day 15, they're decomposing. If you wanted to include the negative as part of your answer, you'd have to rephrase this. The amount of clippings are changing. If you just want to say changing, then you could put the negative in there. Are changing at negative 0.164 pounds per day on day 15. So this one was 1 for the answer and 1 for the explanation. Part C. Find the time t for which the amount of grass clippings in the bin is equal to the average amount of grass clippings in the bin over the interval. Oh, so I do need average value now. I want the average value to equal the amount. So the average value, we already talked about, put it in the wrong spot. Hopefully if I was working this problem and I hadn't already caught that mistake I made earlier, hopefully I'd think, wait a minute, average value, average rate of change, average value again. Hopefully I'd figure something out. So my average value, we accidentally found earlier, was 2.7526, and we want that to equal the amount. Well, I can let the calculator do that as well. How do you want to make the calculator find that out? Because I don't really want to set up an algebra. I'd rather let the graphing part do this. I think that's the easiest way. Just make a line and then figure out where they intersect. I mean, I could set them equal to each other and do some algebra, and that would be fine, but I think just letting the calculator do it is the easy way to go. Second calc, intersection, first curve, second curve, guess, 12.415 days. And for this one, you got 1 point for finding the average value, and then 1 point for finding the time. And if you're keeping up, that still leaves 4 points left for the last part. But if we made it that far, we got 5 of the 9, so we're still on pace for a 3 now. Let's hope we can pick up a few more. For t greater than 30, so t greater than 30, we're not using that formula anymore. The linear approximation to a at t equals 30 is a better model for the amount of grass clippings remaining in the bin. Use L of t to predict the time at which there will be 0.5 pound of grass clippings remaining in the bin. L of t is some linear approximation. To a at t equals 30. So I want to write a line that picks up kind of where a leaves off. So I want to put a line, here's 30. So I want to write a line. What do I need to write a line? What 2 things do I need? A point and a slope. Well, the point would be at 30 comma whatever a of 30 is, and the slope would just be whatever the derivative at a is. This is a tricky one because all the AP problems are going to have a trick in them. It's like, we've never done that before, but you got to have to read carefully and think about it and figure out what's going on. So I need a of 30. I can go to the table maybe. I don't know if that's the quickest way, but so 0.78293. And a prime of 30 I can get from the graph. Second calc, dy dx at 30. Negative 0.055976, so on. I just don't want to be careful I don't round to the end. Use L of t to predict when there will be 0.5 pounds of grass remaining in the bin. All right, well, let's write our line. So y minus 0.78293 equals negative 0.055976 times x minus 30. Or maybe t minus 30, but they would not take off for that. So I want to know when y is equal to 0.5, what is x equal to? And so I can, how I solve that, I could go to the calculator, or I could just put 0.5 in for y and do the algebra. And I don't have to show my algebra steps. So 0.5 minus 0.78293. I'm going to kind of do the algebra on the fly here. And then I'll divide by negative 0.055976. Oops, I was supposed to divide by the negative of that. That divided by negative 0.055976. and then add 30. So it's after 30 days. That's good. Otherwise, we would have been something not right. Predict the time. So it doesn't tell me what to round to, so 35.054 days. The point values for that were 2 for this expression, 1 for thinking about y equals 1/2, and then 1 for the answer. So it would have been hard to get. This was probably an all or nothing type thing. And that took right at 15 minutes, so we're right on time, and that was me trying to go slow and explain. I want you to try 4 and 5, so your job is to try 4 and 5. In theory, that means you have 30 minutes of calculus homework. Answers are posted, so you can check your work.